Hello everyone. Myself Soham Das. So, today I am going to teach about the reaction mechanism chapter as you see in the screen. So, first of all, I introduce myself. So, as you can see, this is my picture, and my name is Soham Das, and I completed my MSc from the Chemical Science branch from Indian Institute of Technology, Jodhpur, and my passing year was 2025 in the last week of June. So this is a small introduction of me, and currently I am working as a content developer in for IIT Jee. So let's start. So today I am going to teach about the most important chapter in the JEE point of view, that is reaction mechanism. Some small part I am going to teach. So before going to teach, this is a small students. Hope you are well. Let's start with the enthusiasm. So let's start. So this is reaction mechanism. So let's reveal what I will teach today. So some overview I will give you. So first of all, before going to the reaction mechanism, uh, we have to know about the what is the basic of the reaction mechanism. Before first of all, I just reveal this part. So first of all, we have to know about the bond cleavage portion. So in the bond cleavage, there is two type of bond cleavage which I will discuss in the later. That is heterolytic bond cleavage and homolytic bond cleavage. And in the third part, I will discuss about the most important basic concept of reaction mechanism chapter, that is carbocation, carbanion, free radical, carbene and nitrate. But this is short video, so in this video I will discuss just one reaction intermediate, that is carbocation. Okay, so before go to the beginning part. So first I will discuss what is reaction mechanism. Okay, as you've seen here, two types of substrate is present. Okay, and from these two types of substrate, the new product one and second product is product 2 is produced. So here as you can see, the first bond is cleaved and the second substrate of second bond is cleaved. So this is the old bond, and these two new bond is formed, and this is the new bond. Okay, so let's see. So this is totally depend on the electrons moving activation energy. So in the reveal what is the basic definition of the reaction mechanism. So yes, so as you can see, what is I have wrote here, I have written here a sequential account of each step describing details of electron movement. This is very important. Energetics during the bond breaking, because due to the bond breaking or bond making, in the beginning of bond making some energy is released, but in the bond breaking portion some energy is required to break that bond. Okay, so bond formation and the rates of transformation, as you can see. Okay, rate of transformation reactant to product is referred as reaction mechanism, as I told before. Okay, so here the next, what is bond cleavage? Let's reveal the definition of bond cleavage. Okay, so as you all know, as you can see here, bond cleavage is the process of breaking chemical bond between two atom. So here as you can see here, the two atom or two substrate. Okay, two atom means this is a atom and this is atom 2. Okay, so here the bond is broken. So this same thing is written here, that process of breaking a chemical bond between two atoms, it can occur in two ways depending on how shared electron pair. So how the substrate is shared their electron pair. So this whole procedure is depend on this. Okay, so based on this electron pair sharing, here is two type of bond cleavage. First one is heterolytic bond cleavage and second one is homolytic bond cleavage. Okay, So regarding the heterolytic bond cleavage, I will I will show something. So here, as you can see, this is the basic structure of heterolytic and homolytic bond fusion. Okay, so heterolytic bond fusion is mainly depend on the unequal electron sharing. Okay, so unequal means if carbon contain the positive charge, so here it is electron deficient. Okay, electron deficient. Okay, and the other one is electron rich. This is electron rich. So as you can see here, the sharing of electron pair is unequal. Okay, and the same is the vice versa. When the carbon will be electron rich, other portion will be electron deficient. So this type of bond cleavage is called heterolytic. So here, as you can see, cleave in which unequal distribution of electron takes place during bond cleavage is known heterolytic bond cleavage. Okay, so this is unequal distribution. Okay, due to unequal distribution of electron, ion is formed. Okay, ion is formed. As you can see here, this is two ion, carbon positive or Z negative. Okay, ion is formed. That's why also known its ionic cleavage. So heterolytic bond cleavage is also known as ionic cleavage. Okay, as you can see here. Let's move to the homolytic bond cleavage. So homolytic bond, in the homolytic bond cleavage, this is anionic bond cleavage, means here sharing of electron pair will be happened. As you can see here, no ion is present, no ion is present. So let's reveal. So here, as you can see, this is homolytic bond cleavage, cleavage in which equal distribution, this is very important words, equal distribution of electron takes place during the chemical reaction is known homolytic cleavage. Due to equal distribution of electron without charge, unpaired electron without charge, so these species are formed which are known as free radical and cleave is called anionic cleavage or heterolytic fission. Hope you understand these two type of bond cleavage. Okay, now let's move to the carbocation section. Okay, so what is called carbocation? So as you can see, this is basic skeleton of carbocation. Okay, let's review. Okay, so carbocation are defined as species with positively charged carbon atom having three covalent bond. So as you can see here, three covalent bond is present. So what is the best important and basic point related to this carbocation? I will just reveal. Okay, so as you electron deficiency, it acts as electrophile and always attack on the electron rich center. What move to the study, it is incomplete octet species. As you can see here, three covalent bond. So here two electron pair, here two electron, and here two electron. So this is six electron pair is present, but octet rule, 8 electron pair should be present. Okay, 8 electron pair should be present, but here two electron pair is missing. So that's why here I wrote that incomplete octet species. It has 6 electron pair outermost shell. Okay, so all electron are paired electron. Okay, so this is the how the carbocation is formed. This is the basic structure. So as you can see, this is one compound. It has tetrahedral structure. As far one atom leaves, uh, this atom is leaves, and as you can see, this is sp2 hybridized and trigonal planar shape. Okay, it has one vacant p orbital because one atom was left, so for that reason it has one vacant p orbital. Okay, so this is the basic stability order of carbocation. So first we will prefer the dancing resonance, second aromaticity, third mesomeric effect, fourth equivalent resonance, fifth regular resonance, sixth hyperconjugation, seventh inductive, and eighth S character. Okay, so sp hybridized carbocation highly unstable because you can see based on this effect, here is some example. So this is the dancing resonance. So here is 3 cyclopropyl ring, and also the dancing resonance will be happened when the cyclopropyl ring was is attached to the carbocation. The more number of cyclopropane ring, if the more number of cyclopropane ring is attached to the carbocation, more dancing resonance will be effect on that carbocation, and that carbocation will be highly stabilized. Okay, so this is the basic concept. And after that, this is aromaticity, as you can see here, 4n plus 2 pi electron, and this center is sp2. Okay, so this is aromaticity, and this is highly resonance. Okay, because here, as you can see, this carbocation delocalized by the 3 phenyl ring. So for that reason, this is highly resonance affected, and this is mesomeric affected because oxygen lone pair donate here to stabilize this carbocation. So this is mesomeric affected, and this is normal resonance. Okay, the just delocalize this pi bond. By the delocalizing this pi bond, this carbocation is stable. Okay, so and this is also the normal resonance, and this is the hyperconjugation. Here presents 9 alpha hydrogen. You can know what is called alpha hydrogen. The carbocation attached group has the hydrogen number, because here is 3, here is also 3 hydrogen, as here is also 3 hydrogen. So this is called alpha hydrogen. Okay, so yeah, so this is the more number of alpha hydrogen, more will be the stabilized carbocation. Okay, this is the basic concept. Don't, and this is the allylic carbocation. So here is some, here is some one basic correction, that I just carbocation is too much stable than this carbocation. Okay, so this allyl carbocation will be placed here, and this will be placed here. So, okay, this is basic mistake, so don't judge it. The carbocation, as you can see, this is sp carbocation, so directly attached to unsaturated carbocation. For that reason, this is also highly unstable, highly unstable. So for that reason, I just merged up these 3 carbocation. Okay, that is bridged carbocation. Bridged carbocation is rigid. Bridge system is rigid system, but as you can see before, for the formation of carbocation, there is sp2 means 120 degree, but this is rigid system. Here 120 degree, uh, here mainly ring stain is present, so 120 degree is not from here. So for that reason, this carbocation is too much unstable. So here, as you can see, bridge carbocation are not stable due to the non-planarity, because it is also non, because of this bridged carbocation are not stable. So this is the formation step, how the carbocation is formed. So more negative group is left, more electronegative group. First is method 1. In method 1, more electronegative group is left. So as you can see, here is one of the secondary alcohol. It just protonate, just collect the H plus from any acidic group and just left. Okay, so water left minus H2O. So for that reason, here one carbocation is formed. As well as the same process is follows. This is more electronegative. Okay, more electronegative. So this group will be left, and this is one carbocation is followed. But the basic difference of these two carbocation, you can notice, this is B and this is A. Carbocation B is more stable than A. Why? Just think about it. After, yeah, so as you can see here, the delocalization of pi electron is also present, and here is not. Here just 5 alpha hydrogen is present. As you can see, here is 3 and here is 2. So 5 alpha hydrogen can present. Based on this, this B carbocation is too much stable. Okay, and this is the method 2. Method 2 is simple, just double bond collect the H plus, and here the secondary carbocation is formed, and here the tertiary carbocation is formed. Same reaction, but this reaction B is also more stable than reaction A. Why? Because here alpha hydrogen, you can judge it only the based on alpha hydrogen. You can see here 9 alpha hydrogen is present, but here 5 alpha hydrogen is present. Okay, here 9 or here 5. Okay, so this is the same. This is the reaction of carbocation. First reaction is nucleophilic attack on carbocation. So this nucleophile, this is a carbocation. This nucleophile may be attacked above on the plane or below on the plane. Okay, if it is above on the plane, as you can see, this is above on the plane and this is below on the plane. Okay, and second one is the elimination of hydrogen from nearest carbocation. So this is the elimination of hydrogen. This is hydroxyl group, it's collect H plus and just water removed, and you can see this is stabilized carbocation is formed, and this H is removed, and here is just double bond is formed. So this is elimination product. Third one is rearrangement, which is one of the normally the carbocation A is stable, is not stable. Okay, normally the carbocation is not stable, as you can see here no alpha hydrogen is present, but after 1 2 hydrogen shift, this is 1, this is 2, 1 2 hydrogen shift, as you can see this positive charge is too much stable, because here the alpha hydrogen is 3 3 6 and here is 2, so 8 alpha hydrogen is present after rearrangement. So rearrangement is too much important. Okay, so here the alkyl shift, I here the hydride shift. Okay, so after the carbocation formation you always notice if their rearrangement possible or not. So let's move to the next portion, that is ring expansion. So this is also the same thing based on the alpha hydrogen. If how much you decrease the ring strain, the carbocation is more stable. Okay, so here is 4 member ring is present, but here 5 member. Okay, so as you can see, why? Because this positive charge has just one alpha hydrogen which is here present, but this positive charge here is 2 and here is 2. Oh, so 4 alpha hydrogen is present here. Same reason is here, as you can see here 2 alpha, here 2, here 2, so here 4 alpha hydrogen. So after shifting this bond, here ring contraction give the more stability. So always ring expansion not give the more stability, ring contraction is also the give the more stability, it's based on the alpha hydrogen. So as you can see here 2, here 2 or here 3, so total 7 alpha hydrogen. Okay, here 4, here 7, so this is more stable. Okay, so this rule, golden rule is that, okay, so what is the golden rule? Golden rule is carbocation rearrangement if new carbocation is more stable due to inductive effect or hyperconjugation or resonance. Okay, so that will be more preferable for the next reaction path. So this is a most important reaction, that is pinacol pinacolone, based on the carbocation rearrangement. So let's reveal. So in this reaction the vicinal diol is used. So vicinal diols means this type of diol, and geminal diol means this type of diol. Okay, where the two hydroxyl group attach with the one carbon, that's called gem diol or geminal diol. Okay, so this vicinal diol is called pinacol. So it's just form the ketone like pinacolone. So let's reveal the common acid used or common reagent used in the pinacol pinacolone rearrangement. Okay, so as you can see here H2SO4, HCl, H3PO4 and HBF4 is the common acid used here. Okay, so why strong acid? So just think about it, why strong acid? So when you will use the strong acid, the H plus is easily removed, and this type of hydroxyl group capture that H plus and remove as a water. Okay, but this positive charge is not too much stable due to only alpha hydrogen, but if here the alkyl shift is possible due to the mesomeric effect of this oxygen, this carbocation, if the carbocation shift here to here, then this will be more stable. So for that reason, after that this oxygen lone pair share uh, its electron in this bond, and this alkyl group shift into that carbocation position. Okay, so after H plus remove, and then we will get this pinacolone. This is just alkyl shift Okay, and I added one just for ring expansion. As you can see here, the same uh, procedure will be followed. Water as a removal group will be removed, and after that this ring will be expand, and the positive charge shift here this position, the positive charge shift here, and the oxygen share the electron pair to form this pinacolon. Okay. Okay, so this is one important case. Okay, this is also rearrangement. As you can see, this is benzylic carbocation, this is benzylic carbocation. After shifting of this will be tropylium. This is tropylium cation. Please remember this name. This is tropylium cation. It's very very important. Okay, why this is stable? Because it is delocalized resonance, because this electron is delocalized. Sorry, this carbocation is delocalized due to tropylium cation is more stable than benzylic carbocation. Some basic remember, 2 points remember, so this will help to solve your questions in exam. You can just read it, this is very important. Okay, much. If you have any questions, uh, please you can just ask. Okay, thank you so much. Thank you.